This is John Black, Super Chemist. This is just a disclaimer to let you know that this video is not intended to be imitated. No parts of it should not be copied or done by you or anybody. It's just for educational and maybe entertainment purposes to watch. That's it. I don't condone anyone repeating anything in the video. Okay, I'm trying to collect this oxygen in a 1,000 milliliter graduated cylinder. So the first thing I need to do is make sure that I am not making too much gas. I figured I want to make a half a liter. That way I got room to spare, right? Here's your constant, how many liters you get per mole of any gas, or ideal gas. I wanted a half a liter, right? So I divided 22.4 by a half a liter to see how many there were. There were 44.8. So I divided both of these by 44.8. And I got a half a liter equals 0.0223 moles. So here's the formula, right? The MnO2 is just a catalyst. Like any equation, I took the molar masses, I multiplied them what the equation told me. This one said 2, this one said 1. I got my new grams. But remember, I only want to make a half a liter of gas, so I need this many moles. If 32 grams is 1 mole, I need to times that by 0.022 so that I get this many grams. If I do it to this side, I got to do it to that side, right? So I times it by 0.022 and I get this, 1.49 grams. Now, at most, and I titrated this 2 years ago, it was 29%, so at most it could be 30, let's say 33%, right? So that means by weight. So that means that 2/3 of it is water in my bottle, you know what I mean? And 1/3 at most is hydrogen peroxide. So I multiplied that by 3. So now I have 4.5 grams or 4.488. If I have a 33% by weight hydrogen peroxide in there, then I will make a half a liter of gas. And there ain't no way I got more than that. Here's what I'm using. So I got it out of batteries. And you can see in there. Not very pure, but it doesn't have to be. Just has to be good enough. I only put a little bit at the bottom there. I don't know if you can see it. It is a catalyst, so you know I don't need that much. Plus, you figure at most I have 1.5 grams or 1.5 milliliters of hydrogen peroxide. That isn't that much. You know what I mean? Now I'm going to dilute it with about 200 milliliters of water, maybe even more. I'll put it up here, right? So I have my 1.5 milliliters of hydrogen peroxide in here, along with enough water for up to, you know, somewhere around here. Because this stuff produces gas so quick, it's unreal. If you just put that 1.5, drip it in here, it'll blast it. I want it to make slow oxygen, not a lot, you know, not all at once. You can see I got the tube here, comes up. Now it's only just hanging right there, but I'm going to put it down there inside this water. I'll go up to the graduated cylinder. You can see I took all the oxygen out. I mean, there's no air in there at all, not even a little bit. I got 4.6 grams of hydrogen peroxide in there. I'm going to try to do this as slow as possible. See my drip rate. It's actually too fast. Slow it down. It's a little better. Not great. I can even see it going from the hose. Oh, there we go. I'm very happy about the speed of this. It's actually going so slow I might speed it up. First time I did this, man, that thing flowed up in like a half a second. Scared the heck out of me. Wow. Didn't even get 100 milliliters. I guess it's still making it. Well, we'll give it time since it's so dilute. I never had it that dilute. I usually go a lot faster than that. But I'll get back to you. I guess a good idea would have been to have this under a stir bar. I gotta keep moving it back and forth like this. I can stir, and I get more oxygen. Guess I'm gonna have to stand here and wait and keep manually stirring it. Well, it's almost up to 100 milliliters. I would like it to get to 5, even though I know it's not. 300 would be good. Well, no matter how much I shake it, it doesn't produce any more bubbles. I evened that out and leveled it. It's at 337 milliliters. So let's do the math. Actually, I'm going to do this one more time, then I'll do the math. Now this time I have less water and more MnO2. Same exact amount of peroxide. Time I got a stir bar too. Tripping in quick. Turn the stir bar on. Here comes the bubbles. You can see in there, bubbles forming. This time it's going to be a lot quicker. I got a stir bar too. How fast it's going in. It's almost in. Just because it's all in, you got to keep stirring it so you don't get any more bubbles. We're already getting a better titration using this stir bar instead of me having to manually. I just got sick of doing it on the last time because it's making more oxygen this time. You can see it's almost the same. A little bit better this time because I have the stir bar. Alright, I'm going to take the second titration because that first one was kind of BS without the stir. Here's your formula. Now, I got 350 milliliters or 0.350 liters, right? So I divided that into this. This is my constant, right? That's how many liters a mole will make. I get 64. That means I made 1/64th of this. So that means I made 1/64th of that, of a mole. So I take 32 grams here and I divide by 64, and that's how much I made. Because I made, if this is a mole, and I made 1/64th of a mole, then if I divide, I get a half a gram of oxygen that I made, right? Well, I'm going to do the same thing over here. I'm going to take a 68 grams, see up here on the top. Well, I only want 1/64th of it, so I divide by 64. It says there was 1.06 grams, right? Now, if you remember, we weighed up both times the same amount, 4.6 grams, right? So to do percentage, you divide the total by that fraction, and you get 0.23108, so you might as well say 23%. Now, that's been in my refrigerator. That's like 2 or 3 years old, and it started out at 29%. So that's not bad. You know what I mean? That long, 2 or 3 years. I did have it in the refrigerator half of that time. The other half, first year, I just left it out in the, in the room or whatever, room temperature. Anyways, that's how you make oxygen, and that's also how you titrate your hydrogen peroxide. Always remember, science is great.